All right, this is a little video on heat transfer and the concept of endothermic versus endothermic processes. And this is a video that you should watch going into Unit 7, our thermochemistry unit, okay? So let's talk about heat transfer first, and then we can get into these other terms. Heat transfer is just energy in the form of heat moving from one place to another, and this is not a terribly difficult concept. Anytime something warms up or cools off, that heat has been transferred either out of or into an object or a substance, and that's really all heat transfer is, the movement of heat energy. Okay, but we do need to have an understanding of what this from one place to another really means, and because those terms become important as we move on here. So we're going to talk about these two words, system and surroundings, okay? So these kind of represent from one place to another. Those are the system and surroundings. So let's consider that we have this bomb, okay? This is like an old-timey looking bomb. And this bomb has a bunch of chemical potential energy stored up in it, okay? So it's got energy that is locked up in the molecules that are in the explosive compounds within this explosive, okay? So as this bomb detonates, kaboom, you will see and observe a heat transfer from inside of the bomb to the outside surroundings. And so what that means is that the bomb itself and the chemicals that are within it are classified as what we call the system. And the surroundings are kind of the general area that is around the bomb before it goes off. And so the surroundings are relatively cool before the bomb goes off, and then after the bomb goes off, there's a transfer of heat from this system into the surrounding area, okay? So that's what system and surrounding means. So this we have heat energy sort of going from the system into the surroundings, all right? So another example of that in the opposite direction is something like this. Like if we have an ice cube, and you've all seen ice melt, I take it. So if we have an ice cube made of water and we leave this out like on the tabletop or something like that, and we allow heat from the outside environment, which we would call the surroundings, to enter into the ice cube, which we're calling the system, then heat is coming into the system from the surroundings, and what happens to the ice? It turns into liquid water, and that's pretty understandable when you think about relative energies. We know that solid state water has a lot less kinetic energy than liquid state water does. So that energy to make solid ice turn into liquid ice comes from this surrounding heat that is all around the ice cube, okay? Another kind of cool example of this are these instant ice packs, which you've seen, and this is a really interesting chemical reaction that takes place. So, you know, let's say that you're, I don't know, dorking around and you know, knock your head against the table or something like that. You might crack one of these instant ice packs out. And these ice packs consist of two chemicals. We have ammonium nitrate and water that are held separate from each other inside of this instant ice pack. And when you squish this ice pack around, you like break this little barrier that keeps these things apart, and they're allowed to get together and do a chemical reaction. And that actually draws heat energy from surroundings into this system of the ice pack, and it'll bring heat in from everywhere around it, including like if your head is right here, like you've bonked your head really bad, and so this heat energy from your head goes into this instant ice pack, and your head loses heat energy, so it cools down, which is why it feels cold. But believe it or not, this instant ice pack, as it absorbs heat, is actually warming up, which is kind of interesting. Okay, so that's kind of how we would define system and surroundings, is like the area outside of the of the reaction is the surroundings, and then the reaction itself is the system, okay? So now on to these other terms that we said we were going to talk about, endothermic versus exothermic. Okay, so let's start with endothermic. Okay, so endothermic, this term, I want you to think of this as just meaning that heat is coming in, okay? And so when we think of heat coming in, these are the examples that you should be thinking of, okay? So heat is coming from the outside to the inside, so into the system, okay? And so in an endothermic process or an endothermic chemical reaction, we can plot the energy on this little XY axis here. And along the left here, this is the energy. Okay, and this is measured in a couple of different units. We can measure this in joules, kilojoules, calories, or even kilocalories, okay? So those are a few different units that you'll see as we move forward. And so really this definition sort of sums up an endothermic process. The system starts with relatively low energy, and over time, heat is absorbed, and the system ends with higher heat energy. And so the x-axis here is the time. Okay, I'm going out in these directions here. Okay, so let's take a look at what that graph looks like. So if our system starts with relatively low energy, and then over time it climbs up in energy, and then it always kind of ends up leveling out like that. But that's like what's happening here. So the ice started out as relatively low energy, and then it absorbed all this heat coming in to become this higher energy liquid water. Okay, that's what endothermic means. Exothermic is just the opposite. Just think about exo as exiting maybe, or something like that. So this means heat out. And same thing with our axes here. We've got energy, which is joules, kilojoules, maybe calories, that kind of thing. And this again is time. Okay. And so in an exothermic reaction, the system starts out with a relatively high heat energy, and then over time, which could be a really brief amount of time, or it could be a prolonged amount of time, releases that energy into the surroundings, and the system ends up with lower heat energy than it started with. So that graph looks a little like this. We start relatively high, and then over the course of time, energy is released, and we end here with low energy product, okay? Low energy system. High energy, over time losing energy, and ending with lower energy, okay? So that is a pretty good summation of heat transfer and this concept of endothermic and exothermic processes, okay?